Hello everyone, welcome to our channel. This is Dinesh MA working as Assistant Professor in the Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. In the last session, we understood the concepts of op-amp, the fundamentals like the block diagram representation of a typical op-amp, the characteristics or the parameters of an ideal op-amp and a typical op-amp, and also the equivalent diagram of an op-amp. And in this session, we'll understand the open loop configurations of an op-amp. An op-amp in open loop configuration works in three different modes. Those are differential mode, inverting mode and non-inverting mode. Let us get into the differential mode first. So we can see the circuit diagram here, and in this we have two input signals V in 1 and V in 2. And these two signals will be applied to the input terminals V1 and V2 through the resistance R in 1 and R in 2. The values of R in 1 and R in 2 are negligible with respect to the input resistance of the op-amp. And A is the open loop gain of this op-amp and V0 is the output voltage. And as we have discussed, the op-amp is going to amplify or sense the difference between the input voltages V1 and V2, what we call as VID, and that will be amplified. So the output can be written as V0 is equal to A into VID, where VID is the input differential voltage. I mean to say this is the difference of the input voltages V in 1 and V in 2. So this can be written as A into V1 minus V2. So where V1 is equal to V in 1 and V2 is equal to V in 2. So V0 is written as A into V in 1 minus V in 2. So this is the output voltage of this op-amp circuit, and the polarity of the output depends on the differential input voltage, that is V in 1 minus V in 2. So this is differential mode of op-amp. Now the next type of mode is the inverting mode, and as we can see here in this diagram, there is only one input, whereas in the differential mode we had two inputs. In inverting mode we will be having only one input signal source, that is V in, which is applied to the inverting terminal V2. Yes, so the input signal V in is applied to the inverting terminal V2, whereas the non-inverting terminal V1 is grounded. Now again, A is the voltage gain, open loop voltage gain of this amplifier, and V0 is the output. So the general equation V0, which is nothing but A into VID we have, right, where VID is nothing but V1 minus V2, and V1 is connected to ground, which is nothing but 0, and V2 is connected to V in. So output is going to be A into 0 minus V in. So that output can be written as minus A into V in. So here what we can see is the output expression is the negative gain of the input signal applied, right. So what does this negative sign indicate here is, this negative sign indicates the output will be 180 degree out of phase with respect to input signal. So that is what this minus signal is indicating. So this is inverting mode operation of an amplifier. Now coming to the third mode, we have non-inverting mode. So here too we have only one input signal source, that is V in, and this has been applied to the non-inverting terminal V1, whereas the inverting terminal V2 has been grounded. right? And A is the open loop gain and V0 is the output voltage. Now V0 is written as A into VID and VID is written as V1 minus V2, where V1 is Vin and V2 is grounded, which is nothing but 0. So output is going to be A into Vin minus 0. So V0 is equal to A into Vin. So here we can see output is positive, which means output will be in phase with the input voltage, right? So these are the three modes of an open loop op-amp what we have. So let me repeat this. So we have three modes. One is differential mode, where we'll be having two different input signal sources and these two will be applied to the input terminals V1 and V2, and op-amp will be amplifying the differential voltage, that is difference between V1 and V2, and the output is given by A into Vin1 minus Vin2. And in the inverting mode, the input signal Vin will be applied to the inverting terminal V2 and the output is given by V0 equals to minus A into Vin, where the minus sign indicates output signal is 180 degree out of phase with Vin. And in the non-inverting mode, again there is only one input signal source which is applied to the non-inverting terminal V1 and the inverting terminal V2 will be grounded and the output voltage V0 is given by A into Vin. So in all these three modes, A represents the open loop voltage gain. These are the three different modes in which an op-amp works. So that's all what we have for this session. In the next session, we'll understand some of the applications of an op-amp. Thank you.